Hi everyone, let's go ahead and get started with the statistical operations into a Numpy. We are going to basically see here how you can get the mean, variance, standard deviation, median, minimum and the maximum values from the Numpy array. Let's go ahead and create a Numpy array. So I say here a equal to np dot array, and in this array I'm going to pass here 1, 2, 3, 4, 5 and 6, 7. This is just a random number, you can take any numbers. In this number, I'm gonna get first a mean. So to get the mean, you can simply say here a dot mean. You will automatically get here a mean value. So a dot mean is one way to do that. Another way to do that, you can do like np dot mean, in that you pass the array a. So in these both way, you can find out the mean value. Otherwise, if you take this list simply, suppose that you have a list and you want to get the mean value, you can simply pass this list where you will be getting the mean value. So these are the ways to get the mean value. Although this seems like a standard Python value, a standard Python method to get the mean. And here this one is a Numpy method to get the mean. Let's go ahead and similarly try to find out the variance of an array. So I say here a dot variance. So in that you get here a variance. So again, mean is 4 and variance is also 4 for this data. Let's go ahead and see standard deviation. So for standard deviation, I say here std. So std is 2. A dot variance, I'm gonna say 4 and std is 2. Let's go ahead and see what is the median of the value. So a dot median, and in this I think we did not get the correct result there. All right. Let me see how you can get the median. Anyway, seems like we are using a correct method. Otherwise, if this is not working, okay, so you can get here a standard Numpy way to get the median, np dot median here, and in that you pass the array. So again it says that the median is 4. So the median is a number which is sorted into ascending or descending order, and middle value is a median. Now you see there the median and mean are equal for this particular data set. Similarly, if you have a multi-dimensional array, for example, if I create here a 2-dimensional array, so the same method you can apply into your 2-dimensional arrays as well. So I'm going to say here 11, 22, 33, 44, 55, 66, 77. This is a 2-dimensional array. So in this 2-dimensional array, if I say here a dot mean, now you see there you get the mean value of these whole numbers together. If you add the numbers and then divided by 14, you will get here a 24. Similarly, you say here np dot mean and you pass here array a, then again you get here a 24 value. So all the procedure which we did earlier, like np dot median, and in that you pass array a, it says that the median value of this array is 9 there. Alright, perfect. Similarly, you can do here for a standard deviation and variance as well, like a dot var, that is the variance, and again a dot std, there you do, this one is the standard deviation. Alright, perfect. So this is all about in this lecture. Thanks a lot for watching this. I'll see you in next one.